Welcome back everyone to another video in our FE Civil Preparation course. In this video, we are going to talk about soil classification using USCS method. In our last three videos, we learned about multiple soil tests. The results of these tests help us to classify the soil into multiple groups. We have two classification methods for the soil that we are going to study for our FE exam. The first classification we will talk about is based on USCS, which is Unified Soil Classification System. In this classification, we can see that the soil is classified into 15 different groups, starting from GW, which is well-graded gravel, and GP, which is poorly graded gravel, up to OH, which is organic clay or organic silt, and PT, which is peat. In this method, we have this table as we can see here, and we will use certain parameters for the soil in order to identify in which group does the soil belong. In order to identify the exact type of the soil, we start checking our soil in certain order to eliminate options and narrow our choices. In the USCS method, soil are classified into two main categories, which are coarse-grained soil and fine-grained soils. The separator between these two categories is the percentage of soil passed from sieve number 200. If more than 50% of the soil are retained at sieve number 200, this means that the soil is coarse-grained soil, and if more than 50% of the soil passed from sieve number 200, this means that the soil is fine-grained soil. If the soil was found to be coarse-grained soil, we will keep going forward by checking another parameter, which is the percentage of soil retained on sieve number 4 to find out if the soil is sand or gravel. If more than 50% of the soil are retained at sieve number 4, this means that the soil is gravel. And if more than 50% of the soil passed from sieve number 4, this means that the soil is sand. And we will keep checking further parameters such as CU and CC, which we have discussed earlier how to calculate them, and based on that we will be able to accurately identify the soil group. However, if the soil was found to be fine-grained soil, we will keep going forward by checking another parameter, which is the liquid limit of the soil. If the liquid limit of the soil is less than 50%, this means that the soil is one of these three groups of silts and clay. And if it is more than 50%, this means that the soil is one of those three groups of silts and clay also. After that, we are going to check if the soil was found to be organic or inorganic, which is going to be given in the problem, and this limits our option to either these two groups of soil or these two groups of soil. In the next stage, we are going to use another graph to accurately identify the soil group. Here we can see this graph that is used to classify fine-grained soil. This graph shows the relation between the liquid limit in x-axis and the plasticity index in y-axis. We have here this vertical line at liquid limit value of 50%, which is separating the soil into two main categories at the right and the left here, and we have already discussed that in our last table. However, in addition to that vertical line, we have another two inclined lines here, which are called A line and U line. Those two lines are separating between different groups of soils, which means we have to draw these lines to understand the relation between our soil and those lines. The equations for those lines shown here on the graph are very simple. The equation for line A is plasticity index equals 0.73 multiplied by liquid limit minus 20, while the equation for line U is plasticity index equals 0.9 multiplied by liquid limit minus 8. For any given soil, we need to calculate the plasticity index of the soil and to compare it with the plasticity index calculated to accurately identify the soil group. I know that this might seem confusing right now, but you are going to realize how simple it is once we start solving an example. So let's check it now. So let's check this example. We have an inorganic soil with these characteristics, and we want to identify the classification of this soil. So as we learned, first thing we will look at is sieve number 200. We can see here this is the fraction retained on each sieve. You have to take care here that the biggest sieve is at the bottom So we are starting from here. It's 2, and this is one between 2 and 0.75. This is between 0.75 and 0.05. So it is getting smaller as we go in this direction. So we are calculating from here. At sieve number 2, 0% retained. At the second sieve, 0.29 retained. And we can see here that if 200, it equals 71%. If is not the retained, if means finer. So this means that 71% of the soil is finer than the sieve 200, which has the opening of 0.075. So this is the first and very important data, that the retained soil at sieve number 200 is 29%, because 71% is finer than 200. This means that the retained is 29%. So if we go here, we know that all this part is 50% or more retained at 200. This is 50% or less retained at 200. And we know now that the finer is 71, so the retained is 29, which is less than 50%. So our soil will be in this area here. Let's highlight this part. This is our soil. After that, we need to identify the liquid limit, because this part is less than 50% and this part is more than 50%. We know here that the liquid limit is 53%. So this means that these are the two soil that could be our soil, or three types actually. Now we limited our options to CH, MH, OH, and the peat. Okay, third step, we know here that it says it's an inorganic soil, and this part is organic, and this is the only inorganic. So now we are limiting our options between only the CH and the MH. We managed to limit our options to only this two soil, CH or MH. So the next stage, we will go to the curve as we learned. We have this curve here, and now first thing we need to calculate this A line, because we know our soil, this is the liquid limit and this is the plasticity index. So the liquid limit of our soil is 53. So our soil is somewhere here. If this is the 53, it is somewhere over this line. This is the 53. We want to calculate the plasticity index for this soil, and actually the plasticity index is known as 31 here for the soil. We want to calculate the A line so we can know if the 31 is less or more, because this is 31 here. But you need to realize that this line actually here is not on a scale. I mean, if this point is not corresponding to this point, this line could go higher or lower. We need to calculate this line based on this equation, which is A line, the plasticity index equals 0.73 liquid limit minus 20. So it's 0.73 liquid limit, which is 53 minus 20. So we calculated it's 24.09. So this point is at 24.09 at line A, and we have that the plasticity index of our soil is 31. So our soil is here. It's above the A line and at the right side from the 50% liquid limit. So our point is here. So it's either CH or OH. Let's go back to our original table. It's either CH or OH, but we know that it is inorganic, like we said. So it is only CH. This is the only option now, because OH is organic. It is pretty simple, but you just have to follow these steps, and you will keep narrowing your options one by one till you reach the final option. So this is the answer, CH number A.